So you have an idea as to which claim can explain what happened in those missing seconds. But today, in lesson 17, we need to consider what causes a greater change in velocity. This is important because in either claim, the pod changed its velocity. We need to know how that could have happened. Today, you're going to need a pencil, your journal slip, your science journal, and some simple materials. I need you to get a rubber band along with a bottle cap from a water bottle, and you'll also need a chair or a stool. To answer today's question, we're going to exert different forces on that bottle cap. We'll start with the cap at rest and observe its change in velocity. Remember, velocity is how fast the object moves in a particular direction. So for this part of the lesson, I would recommend moving to an area with a smooth surface where you have chairs or stools available. I worked in my kitchen, and what I created was this launcher right here. To do this, you just take your rubber band and you put it around the bottom rungs of your chair or your stool, and that'll hold it in place. And then what I did is I put 3 different markings on the ground. This helped me to know just how much force I was applying when I was pulling back on the rubber band. And when you actually use the launcher, make sure you have the cap right up against the rubber band, as you see in the picture. Take a minute to create your launcher now. All right, you're all set up. So what I need you to do now is you're gonna have some fun with your launcher. You're gonna pull back the rubber band to the different markings, like you see on the screen. Again, that's gonna enable you to apply different amounts of force to the cap. And as you do that, I want you to observe the velocity of the cap as it travels. Remember, the cap's gonna move with a certain speed in a particular direction. Play around with your launcher. I want you to see if you can figure out the relationship between the strength of the force you're applying to the cap and the speed at which the cap travels. As you're playing around and launching the cap using different amounts of force, write anything you're noticing down on your journal slip in part 1. Go ahead, have some fun. So what did you figure out? Take a moment to answer the questions under part 1 of your journal slip. To make sure you've figured out the relationship between strength of force and velocity, let's apply your observations to a new situation. Look at the setup on the screen. We have object A and object B. They both start moving to the right with the same velocity. We can see that based on these blue speed markings. Now, what can you infer about the strength of the force exerted on object A versus B based on the differences you see in the velocity change? Here we see A has sped up and still moving to the right. B has also moving to the right. Take a moment to think and write down your thoughts on your journal slip under part 2. You got it. A stronger force must have been exerted on object A because object A sped up more than object B. You probably noticed that when you were playing around with your launchers. And the forces must be exerted in the same direction as the movement of both objects because both objects are still moving to the right. Take a moment to draw in the force arrows on your journal slip. So a force causes a change in velocity, and the relationship between force and velocity change is proportional. What that means is that as the magnitude or size of one changes, so does the other. So a greater force can cause a greater change in velocity. This is a key concept, and I want you to write this down on your journal slip. All right, it's time to do some modeling. Yes, we can still model even from home. For each row that you see here, I want you to model the force that would cause the particular velocity change. So, for example, in row 1, you see the object moving at a medium velocity. But then a force must have been applied, and then afterwards, we see the object moving with a slower velocity, but still to the right. What force must have been applied to cause this change? what size and direction would you draw the force arrow? I mean, is it this one? Is it this one? This one? This one? This one? Or this one? Draw that force arrow right here, right now. Take a moment to think about it. Now think about the next row. The object is moving to the right with a medium velocity, but then a force is applied so that the object actually stops moving because we don't see any blue velocity markings. Which force arrow would you draw? What's the size and direction of the force that was applied to cause this change? Again, is it this, this? Which one is it? Take a moment to draw that in right here. Now in the last row, the object is moving to the right with a medium velocity, and we know that a force is applied that causes the object to change its direction and speed. Now the object is moving to the left, but it's moving slower, as you can see from the markings. Which force arrow is it and why? Draw the arrow in the middle panel right here and make sure you write why you think so. You should justify each of your choices. Make sure you're writing in your justifications as to why you think that particular force was applied. All right, there's actually two things to submit today. First, we want to see your launchers in action. On camera, perform at least one of those trials from earlier in the lesson and submit it. Oh, and remember that cup from an earlier lesson? My kids and I had some fun and used the cup as a target. We took turns using the launcher to see who could hit the target. Here, just take a look.
3, 2, 1, launch. Oh, you got it.
Okay, I'll let you think about how many video takes I did with my kids before one of us hit the target. But because we did so many trials, we definitely started to learn something about forces, strength of forces, and velocity. If you get bored today, have some fun with your launcher. You'd be surprised how you'll start setting up mini challenges for yourself. After you submit a video of your launcher, make sure that you complete the Google form for today. Have your journal slip handy so that you can refer to it when answering the questions, because the questions are the same ones from part 3 of your journal slip. Until tomorrow, keep thinking, keep learning, and have some fun with your launcher.